Hallo, hallo, it's Dumplet here. Here's an item on algebra. X, Y, Z, and T are real numbers satisfying the following. Square root of x minus 2014 plus square root of y minus 2013 plus square root of z plus 2012 plus square root of t plus 2011 equals x plus y plus z plus t divided by 2. And the question asks for, what's the value of x plus y plus z plus t? Now, credits to the Philippine Mathematical Olympiad. I believe this was one of the questions last year. So credits to them for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, so if you guys are just interested in the answer, well, I think you can try to find values of x, y, z, and t, since it's just like a short answer problem. So like the short answer to this item is, alright, x can be 2015, y can be 2014, z can be negative 2011, t can be negative 2010, and that's going to be a solution if you try to substitute it. Anyways, the right side becomes 2015 plus 2014 plus negative 2011 plus negative 2010 divided by 2. And then the left side, if you realize, it's just going to be square root of 1 plus square root of 1 plus square root of 1 plus square root of 1. So that's going to be equal to 4. So 4 equals, and if you try to evaluate this sum, that's just going to equal 8. So 4 equals 8 over 2, and 8 divided by 2, that's just 4. And so it is correct that x equals 2015, y equals 2014, and the values for z and t, they work. And going back to the question, we're just asked what's the sum of those, so it's just technically this one. And since that's equal to 8, well, I guess the answer is 8. So indeed, the answer to this question is equal to 8. But let's try to have like a better approach. And the formal solution actually uses an inequality to solve this item. So you're going to see like why in a moment. But this item actually uses the Cauchy-Schwarz inequality. Now, the motivation is kind of obvious because I have like a bunch of square roots and I added them together. And since x, y, z, and t are real numbers, we're not really just restricted to the positive reals or the negative reals, but to the entire real numbers as like the possible ranges for x, y, z, and t. And we are motivated to use the Cauchy-Schwarz inequality because we can technically remove the square roots. And you're going to kind of see like what this helps. So for example, the Cauchy-Schwarz inequality, it's going to tell us that x minus 2014 plus x minus 2013 plus z plus 2012 plus t plus 2011, that's going to be equal to, multiplied to 1 plus 1 plus 1 plus 1. That's going to be greater than or equal to these square roots. So that's, you might want to look up what the Cauchy-Schwarz inequality states if you're not really familiar with this, but generally speaking, it's one of those nice inequalities, and it's very common in a lot of like math competitions, such as the Philippine Mathematical Olympiad. Anyways, let's try to continue on with the solution. Now I'm gonna simplify this green part, and that's gonna be equal to x plus y plus z plus t minus 4, and then this 1 plus 1 plus 1 plus 1, just make it equal to 4. And then on the right side, I have the sum of squares, which is actually equal to the left-hand side of the given expression. So I think for the blue part, I can just write it as this, the x plus y plus z plus t over 2. And since it's square, we don't forget to square that. So we have an inequality, and what's nice about this inequality that it is in terms of, technically speaking, it's in terms of x plus y plus z plus t. So we can kind of take this to our advantage. So let's just say we make that equal to a. Let's say a equals x plus y plus z plus t to simplify our like writings. Now, all right, it's going to become a minus 4 times 4 greater than or equal to a over 2 quantity squared. Now simplifying the left side, it's going to be 4a minus 16. Simplifying the right side becomes a squared over 4. And then multiplying both sides by 4, it's going to give you 16a minus 64 is greater than or equal to a squared. And this is actually very nice because if I put everything to one side, I'll get a squared minus 16a plus 64 is less than or equal to 0. Alright, But this is a perfect square. You can use your algebra factoring skills to tell you that it's equal to a minus 8 quantity squared less than or equal to 0. Now, a must be a real number because what was a? That's just a substitution for us for x plus y plus z plus t. So the square of a real number is less than or equal to 0. All right, it must take the equality. We must have a minus 8 to be equal to 0 because there's no other way such that the square of a real number is going to be less than or equal to 0. So a minus 8 equals 0. So in effect, a equals 8. And since a equals 8 and we had our substitution that a equals x plus y plus z plus t, that's going to tell us that x plus y plus z plus t is going to equal 8. So that's the longer way to say how x plus y plus z plus t can only equal to 8, and we can verify it from at least the specific solution that we got for x, y, z, and t in the earlier part of the video. Anyways, hope you guys learned something new from this video, and I'll see you in the next one. Bye bye!